Guys, if you're done with the first question, you may start attempting the second question now. But we have around 10 minutes every question, then we're going to discuss answers each and every one of them one by one. If you're stuck, right, please don't stare blankly into the paper because that is absolutely counterproductive. Please raise up your hand and ask a question. Guys, if you're stuck, you raise your hands. So I feel the people. Hey guys, I have one request from you guys. Anyone here is like a Christian, by the way? Oh, can we after this class, right? Can we all take a picture like this and say that we sacrificed Jesus' Day to learn physics? Huh? What do you mean? This is wait, what? Well, like this. Okay, for the memes, okay, later on. Alright, guys, you have roughly 3 more minutes, guys, to attempt the first question. Then we're going to discuss the answers already. If you feel that you are doing much faster than the rest of them, you can attempt the rest of the questions as well, guys. Sketch out. You stop already. Bye. Sorry. This is long. Average the force combined spring case, the spring constant and makes it expansion. What? It's find the spring constant by rearranging this formula. Gain equals to add over at some every all together. Okay. You do read your question properly. What the hell? Yes, the weight is okay, I'll give you a thing. Okay, you're supposed to find the spring constant first. Then with the spring constant, we multiply the new extension, which is going to be 5 cm rate. Oh, yeah, it was originally 20, right? Then extended to 25 months. So you need to find the spring constant first. Then with the spring constant, multiply the new extension here. So you will find the constant for the spring extension. Right now, formula F equals to kx, you rule. You have 1 more minute to attempt the first question now, boys and girls. Oh, actually, go to places. This one here. Wait, this one here. Let's put find graph. Yeah, let's put find area under the graph. Oh, okay. Anyone here physics that is damn good that I can move off, like you guys are story 80 and above in school? Get that? No? Catch up. Let's do the first question together. For those who are stuck, please pay attention. For those who are certain the answers is right already, you may proceed on. You may proceed on with the next question, guys. Everyone pay attention and shut up, don't talk anymore. Alright, shut up. Okay, if you look at the first question here, a bus travels at a constant speed. It stops for a short period of time and then travels at a higher constant speed, guys. So from here, they ask you using the axis in figure 1.1, draw a distance time graph for this bus journey here. Guys, if you have a distance time graph, which component represents the speed again? Which component in a distance time graph represents the speed? The gradient, excellent. So if they say they have constant speed, it basically means to say constant gradient, right? Which the first one you're supposed to get is one straight line here. Then after that, it says it stops, Stops means to say zero speed, right? Zero speed means to say zero gradient, which is a horizontal flat line here, which is very poorly drawn, but it's still a horizontal line. Then the last part here, it says it had a higher constant speed. Higher constant speed basically means to say it has a higher constant gradient, guys. So whatever you want to draw, it doesn't matter. Just make sure you draw the gradient that is definitely, seemingly much higher than, oh my God, Gilbert is here. The seemingly much higher, then it's fine already, guys, right? So, it's supposed to be a straight line and you're supposed to use a damn ruler, right? But you all get the idea, right? I think most of you guys should not have a problem with the first part here. It's fine. Then after that, the next part here, guys, a lift elevator starts from rest. Make sure you guys always highlight the keywords or at least underline it in your exam, guys. It definitely helps, guys. Starts from rest, from the ground of the building, right? And then figure 1.2 is the speed time graph for the motion of the lift to the top floor of the building. Then you see that there is a speed time graph here. Using the graph, determine the distance, guys. You're supposed to determine the distance from the ground floor to the top floor, guys. And if we have a speed time graph here, how do we find the distance again, Cash up? Good. It is basically the area under the graph, guys. And if you're supposed to find area under the graph, you could do it two ways. You could do it the really easy way, right? You could separate this into a triangle, rectangle, and then a triangle. Then you can find all the areas. It's fine, right? Alternatively, if your mathematics is more power, right, you can actually just use the what's it called? Trapezium formula. The trapezium formula, and you should be able to find it, guys. The trapezium formula basically states that A plus B divide by 2 multiply by C, you'll get your answer already, guys. Either way, it's fine, guys. But if you must know the easier way, I would prefer the trapezium method. In this case here, my A, write down the formula, guys. By the way, for all of you guys that don't like to write down the formula, it is crucial that you bloody write down the formula, guys. Right? So it's supposed to be A plus B divided by 2 multiply by C, right? In this scenario here, it will be like 25 plus, how much is this? Anyone got the B? Anyone did the trapezium method? 3.3. That's 0. B, what, how much? 17.5. Sure, I didn't look through it, right? But times your C, which is, the C was the one that is 3.3, right? Yeah. Then literally press everything in the calculator. And you should be able to get an answer that is somewhere around 62 meters. Unless this 17.5 is wrong, if not, it should be the correct answer. 61.9 is acceptable. 61, guys, I repeat this over and over again. Your answer is acceptable in 3 significant figures.
It cannot exceed 3 significant figures though. So if you want to be more precise, then most likely you got 61.9 meters, which is also correct, guys. If you did the calculation, it should be 61.9. All right. Okay, for those who are done with the first question, you may start attempting the second question. For those who have any questions, raise up your hand. You're calculating. 12.5. Is it 17.5? Let me check. 12.5. Junior. Okay, it's 12.5, guys. It is not my mistake. Or is it? It's supposed to be 12.5, guys. Anyone here don't know how to find B, by the way? Do you? Anyone needs me to explain how to find the component B? Everyone B. Sorry? 61.9. Final answer. Do you get it? Yeah. If you don't like the trapezium method, it's fine, guys. There's no that you don't necessarily need to use the trapezium method, especially if you know you're going to be bumped here and you know you're going to make some mistake. Have another 10 minutes to attempt the next question, guys, and then we're going to discuss the answers once again. Oh, anyone want some snacks? It goes to FOX. You first find the FOX with this here, and then find the same thing. It's from 20 to 35, right? It's like the same. Good law, I think it's good. Okay, good. Where do you go? Need to use this for and find the K using this extension can be specified. You find the string constant first, then after you find the import.
tell you what to do. You're supposed to define the spring constant with this weight and this extension. Then with this spring constant, you're supposed to multiply the new extension and you'll be able to find the force. I see everyone is stuck on the extension question. I mean the force question.
Hey, everyone that is stuck on this question, guys, let me tell you how you're supposed to attempt it. Everyone pay attention here. For everyone that's stuck in this question, you're actually supposed to find the spring constant using this weight, which is the force, and this extension, which is from 20 to 35. With this spring constant here, you're supposed to multiply the new extension, and then you should be able to find the force, guys. Please attempt it right now. For everyone that is staring blankly into this question here.
Around this way, right? This way is the one that caused the extension to go from 20 to 35, right? So you can find a spring constant in this way, and using the actual. You have no expression. This is your hand. This string constant here, you're supposed to multiply this new extension, which is from 20 to 35, to find force. Oh, go for it. Yeah, you got it. I did it wrong once. How is this pretty constant? This is 9. Yes, there is oh, because oh, but can you see it in this scenario? In this scenario, but your boss broke up. Yeah, this when you get a high floor in the on this is very 5% is not the force. This force doesn't cause this 5% extension. This force causes this extension. Hey, bro, I have a question. Yeah. This is not correct. It's correct again. Yeah, it's correct. This is not correct. Because to use the focus, it's equal to the down of this other one. Hello. We have what's over. This is that we the spring constant in the fire. So this spring constant to find the new force with this extension. We need to go find yes. Yeah, this is the first step. This is the first step. But it's not my answer. The first step, this is story. Then it's about the connection now. It's about the brain. Yeah, I believe when you get it for everything, it's not that. That full on is actually in the this is a very good example. Always somebody that's what they should do. No, it's not. Nine. You also found the spring constant and you multiply 35 with it. 35 is not an extension. 35 is the new length. Yes. Guys, you have 3 more minutes to attempt question number 2.
I recommend you attempt it more before going for question number 3.
Alright, get it right. Who did it? I think you the first one, right?
This guy here got it right, Reggie.
I think so. You got 18? Okay, what is this box responsible for? It's for right? It's the bucket, right? It's the bucket, right? And all of it was in 54, and then it's 18. So how much should be the max of it? Yeah, and it's converted like 18. In this question, but then. This 18, is only the weight of the bucket. This is what the weight of the bucket and the bucket. Then these are the and so any question why we're doing this? Use so the football to go down for the see.
Okay, guys, let's go through the question together. Okay, everyone, pay attention. Okay, everyone, look at this question here. If you see this question here, first information they give you is a bucket full of oil. A bucket full of oil. The total mass of the bucket of oil is 5.4 kg. So this 5.4 kg is in reality the weight of the mass of the bucket and the mass of the oil, right? And after that, they say that the gravitational field strength is this amount, which is basically your G, right? Then from here, they ask you to find the first thing, which is your weight, which everyone knows by now, hopefully, right? W is equals to mg, right? And in this scenario here, obviously, it will be 5.4 multiplied by 10, which is a simple 54 newtons, right? 54 newtons. I think everyone got this one correct. It's fine, right? Then, after that, it says that the bucket of oil is hung from a spring of unstretched length, guys. In your exam, they always like to do this. Everyone see the number, they straight away think about extension because everyone remembers the formula F equals to Kx, which in this case is not going to be the case. Because the unstretched length, the original length is 20 cm. And the limit of proportionality is not exceeded and the length increases to 35 cm. First question, they ask you to state what is meant by the limit of proportionality. Everett, what does that mean? Okay, that is acceptable. If you all remember how Hooke's law's graph looks like, guys, I mean, the graph looks something like this, right? It will be one straight line, then one point, then it starts to curve like this, right? The limit of proportionality is this point here, where it stops obeying Hooke's law, or the maximum stretchable force for the spring to obey Hooke's law. However way you want to structure it is fine, guys. The mark scheme here gives that the point where proportionality between force and weight of the extension stops. Oh, it looks very complicated. I think it's better I write an answer here. You can say anything which explains something similar. It doesn't have to be word by word. What I want to write again. The maximum force for spring. Or anything along the lines. For me, I wrote the maximum force a spring can load for it to extend proportionally. Because beyond the limit of proportionality, it will just start bending downwards, guys. You could literally write anything, it's fine along this line. It doesn't have to be word by word. But you should have the graph in your mind, guys. The graph where it starts to curve, that's the limit of proportionality here. Okay. Then this question, which I've been walking around, seeing everyone do a very funny answer. Guys, for this question here, the next part here, it says that the oil is poured into a measuring tank. The empty bucket right now stretches the spring to a length of 25 cm. They want you to calculate the force that stretches the spring into 25 cm. In other words, they want you to find the weight of the bucket, right? You are finding the weight of the bucket, right, in this scenario here. So, in order to find the weight of the bucket, first and foremost, it should be F equals to Kx, right? In order to find the weight of the bucket, you need to know the spring constant and the extension, which in this case here will be 5 cm. But before you can find the spring constant, you need to use the information that you originally had, because this weight, which is also its new force, let me use a different color. This weight, which is this new force, caused the spring to extend by this amount, guys. Right? So from here, what you're supposed to do is you're actually supposed to find the spring constant first. K would have been equals to F over X. In this case, would have been 54 newtons divided by, in this case, 15 cm. And your answer here, guys, would have been, how much? 3.6. What's the units for this scenario here? What's the units? Xizhen? Good, it's N over cm. Remember how I told you guys in class, by right, the spring constant should be newtons per meters, guys. But there are exceptions. In this case here, we can leave it in newtons per cm because the new information that we're going to use later is also in cm. And ultimately, we just want the force, right? So cm cancel off each other, right? So from here, with this spring constant, I know that, okay, right now I can use the new formula already. The force that was the weight of the bucket is equals to your Kx, right? Which in this case would be 3.6 multiplied by not 25, guys. It should be just 5, right? Because the original length was 20 and the new extended length is 25. So from here, what you're supposed to do is press everything in the calculator and you'll get how much? 18 newtons. And bam, you have the answer here already. Anyone don't understand what I'm talking about for this part here? There's quite a few information that you need to derive part by part. Anyone wants me to repeat anything I've mentioned so far? Good, 100% absorption rate. And then the final answer here, the mass is not going to be 1.8 kg, guys. It's not going to be 1.8 kg. Why? This right now they want you to find the mass of the oil. This weight is the weight of the bucket. So how do I find the mass of the oil with the previous information? What do we do? dy. What do we do? Macy, what do we do? Just 54 minus 18? Yeah, why should we divide by 10? This one here is going to give you your weight, right? The weight of the oil, right? but they want the mass of the oil, guys, which you're still supposed to divide by 10. So overall, you're supposed to get what? 36 divided by 10, which is 3.6 kg. You're supposed to get 3.6 kg for your final answer here, guys. Okay. There's still more. Okay, then after that, the volume of the oil in the measuring tank is this amount. Calculate the density. What's the formula for density, Evan? Good, excellent. Density is equals to mass over volume. In this case here, it will be 3.6 divided by whatever volume that they give you, right? 0.0045. And if you press that into the calculator, you'll get a very nice number. Exactly 800. Is it 800? Oh, nice. What's the units? kg meters cube away. Right. And explain in terms of their molecules why the density of oil is greater than that of the air. Guys, what's the reason of why is density of oil is greater than air, guys, in terms of the molecules? How's the arrangement? Yes, that's correct. However way you want to structure it, guys, you could literally say anything, but as long as you say that the molecules are closer together in the oil, then that's why it's higher density, guys. Or you could say molecules of the air is further apart. Literally anything along the lines is definitely acceptable. Buddy, anyone got any question from this paper here? Or from this question here? Good, excellent. Please attempt question number 3. For those who have already been looking at question number 3, you'll see that question 3A is a damn standardized question with a damn standardized answer, which I have said multiple times in class already. Let's see how many of my students can work out. Already. What did I say are the 2 conditions for it to be integral? Oh, okay. This statement is the same as this statement of one of the wrong. Now, this also not here. Very good. I don't know how many parts of it found now. This statement is the same thing. Yeah, if the first condition, then what the second condition? Got it right, damn good already, okay? No, you didn't. I remember right next to you. Yeah. I was thinking, should I find your father?
Angle in the middle of Thailand.
You're lucky. You're lucky.
Yeah, think about it.
That's too much over. Just like they don't on the slide. Oh shit, forgot to write down the time. No, there's only two conditions. Okay, imagine this right now, you're in equilibrium right now. Why? You're very shady, you're very. So it's all the condition. All the second condition, think about it. You use the square, one, you fall down. No form actually. Yeah, why you're not falling down from the square? It's so many other points, whatever. Sorry. And is there any form of the yes, that's the compare. Because no doesn't form. No, the total upward force is equal to the total downward forces when there is no rebound force. Did I? Did I? I attend the paper first. Discuss later after exam coming soon, right? Sorry, what? The language condition is there should be no resultant moment, there should be no resultant forms. No resultant moment 就是说 anti-clockwise moment is equal to clockwise movement 嘛。这个 condition 就是 total upward force is equal to total downward force。所以你在这个 diagram 里面找哪一些是 upwards， 哪一些是 downwards， 然后你再找这个 wave which is always acting downwards 1.5 right， 然后你就 balance out。你要搞这个 force。Yes. Good. Daisy's favorite question also this month. Okay. What's the principle that we're supposed to use for this one? If you see a given what? Write it down first. Let's start finding between clockwise and clockwise. Clockwise and wait. Before this and B, then this one. No, nothing okay, nothing, then this is balance. This is when not we have this say you give spring balance. That's a way down. Balance must act in the what are down. Down. You just think down for sure purpose in this thing, right? This force that generates an anti-clockwise movement must be balanced by this force that generates a clockwise movement. It must be good. Look, we are. Look, the thing you are going to family. And force should not especially it's really and everything. Right. In months, if this thing is forward, so everything like this thing must forward and balance all months. Right. Right. So from here we can use the whole movement system. Taking force, we have three more. But that's not enough. Not enough. Sorry. This time come up. Yes. No reason but next time, sorry. Is 6-year-old okay, right now this thing, right? This thing here, this thing against the clock, right? This thing here will be anti-clockwise movement or this way. This way you can generate anti-clockwise movement. This anti-clockwise movement faster than anti-clockwise and that's the opposite. This case will be the clockwise movement. Right. So for example, this thing is being passed. This week, this force actually this force multiplied is to be equal to this force multiplied on this line of the force here is supposed to be 1.8. Wait, shit. You want here's yeah. You have no time to attend the question. Pay attention right now. Listen up. Hey, I've said this multiple times in class, guys. This is a damn standard question with a damn standard answer, guys. The only two conditions for anything to be in equilibrium is when there is no resultant moments. For example, the seesaw, right? If you imagine a seesaw, it will balance in the middle, is because this anti-clockwise moment is balanced off by this clockwise moment. That's the first condition. And the second condition is literally like you guys right now. Your ass is exerting a weight onto the chair and the chair is exerting the exact same weight onto your ass, guys. And what's that condition called? No resultant what? No resultant forces, guys. That's the two conditions that is a must in your exam. This kind of question comes up very, very, very often, by the way. You better, by hook or crook, memorize it or remember it some way or another. In other words, if you want to shorten, the whole answer is no resultant moments. And no resultant forces. Yes.
everyone else starts to remember what I've said before in class. Yeah, you're right.
What are these?
Mhm. Okay, then after that, the next question here. Everyone, I tell you, this moment question is literally right the bane of all the students. Everyone for sure they panic on when they see about moments. But if you think about moments, guys, the dead giveaway is whenever you see the word pivot, for sure they're gonna test you about moments already. The word pivot literally cannot mean anything else. The pivoting point should be a representation that is going to be testing your understanding for moments already. From there, you know that, oh, this question is roughly about moments. Okay, what should I do? Show the value of the reading of the spring balance is 8 newtons, right? So if you think about this whole diagram here, right? If you think about this whole diagram here, right? This force is going to generate, this weight is going to generate a downward force, right? Which is obviously going to be in the anti-clockwise movement. Who here by now still cannot differentiate what is clockwise and what is anti-clockwise? See some panic faces. Maybe you are one of them, maybe you are not. But I hope you all know, right? So from here, I know for a fact that this thing here will generate an anti-clockwise moment. Then this anti-clockwise moment must be balanced off by something else, right? Which in this case here will be a clockwise moment generated here, right? With reference to the pivot, right? So this question here, they say that show that the value is 8 newtons, right? So what's the word equation for moments in equilibrium? Moments are not momentum, guys. What's the word equation? Total what? Total anti-clockwise moment is equals to total clockwise moment, right? Very good, Cheatham. And from here is literally, in this case, because there's only two forces, right? F1 D1 is equals to F2 D2, right? And then substitute all the information that you have extracted so far in. Oh, how much is F1? 6. How much is D1? 10. How much is D1? Alden, how much is D1? Good, it is 40. It is always distance to the pivot, which in this case here is 40. Is equals to F2. I don't know. They want you to show that it's 8, right? So you just write F2 first. And how much is D2? Okay. It should be 30. And literally algebra up, and you'll be able to find that F is equals to 8, right? Because your F2 would have been 6 times 40 divided by 30, right? Which would give you an ultimate 8 newtons. And bam, you showed your answer is 8 already. Easy. And how many marks do you get? Oh, 2 marks only. Okay. Then, next. Wow, why is everyone crying today? Physics. Alright, guys. Then after that, wait, what do we do? From here, the weight of the uniform meter ruler is 1.5 newtons. From here, what I like to do is straight away, I like to label that this is 1.5 newtons already. And they want me to calculate the force exerted by the pivot on the meter ruler. So this force, it could be an upward force, it could be a downward force, I don't know. But if you think back about what you wrote just now, guys, it says that it should have no resultant forces, right? In this case here, it should be the upward force is equals to the downward forces, right? So from here, you start to balance it, no? How much is the total downwards here? Total downwards got 1.6, got 1.5. Okay, so right now downwards, there's a total of 7.5 newtons. And then the upward force you already established, is going to be 8 newtons. This is obviously not balanced yet, right? Because up is 8 and down is 7.5, right? So how much should the pivot be acting on? How much should the pivot force be? It should be 0.5, up or down? Up or down? Good, it is downwards. Then only I can I can balance off the total upward force is equal to downward force, right? So in other words, the pivot will have one specific force acting downwards of 0.5 newtons, which will balance all the forces together, guys. You all understand what I'm talking about? Okay, where they are using. Okay, do you understand the 7.5 and the 8 here or not first? Right, because I'm adding the 6 plus the 1.5 mark, so it's 7.5, right? And then the upwards is 8 mark, right? So obviously this is not balanced yet, right? Because in order for no resultant forces to occur, the total upward force should be equal to the downward force mark. It means to say there should be one more force acting in the downwards direction of 0.5 to balance off these two things, right? Which in this case here will be your 0.5 and your downwards now. You understand or not? Anyone else who understand what I'm talking about? Hey, if you don't understand, you better ask, guys. If you don't ask, you'll never know. Okay, good. If you have no questions, please attempt the next question, which is my personal favorite. The difference between moments and momentum. Oh, make a wish.
I see him, you know him, but very beautiful joy. It's like
What's the equation here? What's the principle that you're supposed to use for this question? So this is the principle of conservation of energy. Yeah. Thoughts? The two formulas for conservation. No. Yes, okay, also B minus MU, which is the first one, and the second one, and A, right? So you can use this too, but in this scenario, you can use an A because you don't have all drivers, you can find right. So you must use M minus MU. Oh, what? No. Yes, very good. It's the principle of conservation of momentum. Although you can use both with that. All right. So for sure, you're going to use it, right? So the next question is: use MB minus MU of A or use MB minus MU of B? But the real answer is. What? Oh, this is correct. Good. This is correct also. Shut up, last. This is wrong. Last one is wrong about here, but. But this they are taking together. So what does that mean? Oh, wait, it was here. Yeah. If they are taking together, we need to say this velocity v what right? Oh, they are taking together.
What? And good. And it's the fund will also be operating under one zero. Bro, what does it say? The 800 one was what? It was 800. Where did it go? But it can pay. We are basically in a thing here, right? Why do you minus the line? Because this is minus one thing. This is two, right? About three, right? How come you know? I mean, you got to see. Yes, Macy. Yes, that's correct. Absolutely. Right on in also that's information. That's the ones. Yeah. Watch yourself find the blue. You get the ends, yeah, it's already. We'll just do it fall. Good. I will This is wrong, right? How come with 1.5 so that because of impulse it change the momentum, right? The change the momentum should be the same thing. Either A or both B. 1,000 is one A, one B. That's all. Yeah.
Guys, you have 3 more minutes to attempt the question.
But don't write negative. Like I said, impulse is the change in momentum. It is change from down from 0 to 100 or 100 to 0 changes in velocity. Yeah. In this scenario, right? Because there is a change in momentum. Or the volume of impulse we write down. So no T, over T will become already. It's MD minus the Q bar. What down to the right? What did I tell you? This is one me. It's my kind of that can look at me. Yeah. Okay. try that one. Try that on the side. And then again. And I'm gonna make it. Oh. That's the policy that gets involved in the formula. Remember this. What?
Guys, you have 1 more minute to end this question here, guys. And we're going to discuss that. Yes, Evan, my boy.
Okay. That does the impulse is just and you can derive it yourself. It's not negative, there's no negative impulse because the change like saying the change is 100. So it's like you can handle there. It's getting all of it. That's an action. Skip it away. Hey, you derive the possible memory using the episode and we didn't define. Thank you. Oh, then the bracket, right? That's why this is impulse and this is impulse. Impulse is the momentum and thus the density.
Okay, we're past time already, guys. Let's go through the answers together. Okay, everyone, pay attention. Look here, especially those who did not manage to solve it. I think most of you guys were able to solve A, guys. So we'll go through it really quickly. Okay, shut up, everyone. Stop talking. From here, this question here is definitely supposed to be the principle of conservation of momentum, right? I recommend you all start extracting each and every one of the formulas, each and every one of the information one by one. It says that a figure 3.1 shows a collision at a very slow speed between two cars traveling in a straight road. Useless information. Car B has a mass of this amount, which is your M2, is moving at this amount, right, which is your U2, collides with car A, which is supposed to be your M1, which is stationary. U1 is supposed to be 0. After collision, both cars travel in the same direction as the initial direction of B. And after the collision, the car is going at 1.3. So this is your B1, right? Then they want you to show that V2 is 0.4 approximately, right? So from here, what you do is you write down the formula first. Principle of conservation of momentum states that the total momentum before collision is equals to your total momentum after collision. So in this case, there's two objects, right? Then it should be M1U1 plus M2U2 is equals to M1V1 plus M2V2. Then literally substitute each and every one of the information in, you should be able to get your answer already. M1 would have been 1,000, your U1 would have been 0 plus your 800 multiplied with your 2 is equals to your 1,000 multiplied with your 1.3 and plus with your 800 multiplied with your V2. Then you do your algebra, blah, 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 blah. You should be able to get V2. is equals to 0.375 meters per second, which is approximately around 0.4 meters per second. Everyone got this right? Yes. Then the next question was the one. Oops, sorry. Please copy first. Everyone got it. Okay. Then after that, this question here, everyone starts to question themselves, right? Because the question looks complicated as hell, right? And quite frankly, I was a bit confused also when I read the question. I'm like, what? What the hell? Impulse exerted by A on B. Then another one, impulse exerted on B by B on A. Let me tell you guys, if you see this question, right, ask yourself first and foremost, what do they want from you? They want you to find impulse, right? This is without a doubt already. So it's literally, impulse is either going to be Ft or mv minus mu, right? All of you guys should be able to derive the formula by now from the F equals to ma formula. For those who do not know, let me just say this real quick. You can derive the impulse formula from the F equals to ma. From here, your F should be mv minus u over t. Derive it, you're supposed to get F equals to mv minus mu over t, and thus Ft is equals to mv minus mu. You're supposed to derive it from the F equals to ma. God forbid it that you memorize the formulas, because there's going to be more and more formulas that you're bound to forget. Okay, so from here, it's just a matter of which one is it only, it's either the change in momentum of A or the change in momentum of B, which if you have tried to write down, guys, in your exam, if you're confused, just write something down. Most of the time, as you write it down, you realize that, oh, it was not supposed to be this way. Write down the formula first, write down the information. You'll realize, doesn't matter if it's change in momentum of A or change in momentum of B, both of them would have given you the exact same answer. In this scenario, let's say, for example, if I go for A, right, which will be this, right, it's literally going to be 1000 multiplied by 0 minus with 1000 multiplied by 1.3, which is supposed to give you a negative 1300. But you do not write an answer here of negative. Instead, you write it as 1300. Why? Because change in momentum is literally the same concept. 0 going to 100, the change is 100. 100 going into 0, the change is also 100. So you do not write the negative value in these scenarios here, guys. Right? Then for B, it will be the exact same thing. If I go for B right now, you'll notice that it is literally the exact same answer, which in this case will be 800. Oh shit. Whatever, 800 multiplied by 2 minus with 800 multiplied by 0.375. And bam, you'll notice that, oh, it is the exact same answer, proving the concept that they are both the same thing. It doesn't matter impulse of A to B or B into A. They are the exact same thing, guys. Oh, and usually if it's 1 mark, it's a big giveaway that it's the same answer. Okay. Anyone's got any questions for this part? Good, no question. Then you move on to the next part, which is going to be the energy chapter. After this question, I want to do this vector diagram with you guys, because I see that some of you guys are struggling with these vector diagrams, and I know that Wesley loves to ask about these vector diagrams. After your energy question, we're going to do this one. But do the energy question first now. How many of you guys did not bring the protractor and compass? We'll do the vector diagram first.
What the hell is this? Eventually, what I just yesterday, some people, they're asked to find the feet until they are looking for this. Okay. What do we do? After gravitational potential energy, to find the speed of the. So you're basically converting the GPU to PE, right? What the hell? We just did it yesterday. Why? Nine hell, learn what? I tell you about in this kind of question, they love to ask when these things. As soon as you get the fact and you see the word speed, they're most likely related. In this scenario, it's definitely the distribution E converting to KE. Write down the formula. Write down GP equals to KE. What do we do then? KE. We're not going to be that water. If you do a little bit, you put a little effort for it, then the easiest subject is called 100%. See that. Oh. Yeah. But then you can put a children in the I don't. Boys and girls, and this question that in theory you're supposed to convert the GP into KE, guys. For those who are stuck with the exact same question. That's what this is for. This is what we do. But you can still use noise include your company spare. I'm done. For those who are done with the energy question, do the vector diagram first. Yeah, I. Next, the this is all. Yeah. Here. Yeah. Thì yeah, yeah. That's keyword. Then you have to find the keyword. Keyword, yeah, the right? Right? You learn the box and okay, all that. You're the one I'll see. Someone and I do think about it with some without any people. Whenever whenever they here, right? And they ask if I can speak most of the time is the phone call when they don't know, I think of the story always my for this is that one for potential significant. But I don't know all the potential energy is one of them significant energy. Okay, that's the case for the yeah. Gravitational potential influence the game. The right problem of taking that's our game. Here. Just back to it. That's going back to wait. Yeah. This one here, one also we can one also be like not operate the same one thing we get I shouldn't be like Okay, no, making sense.
Let's go through the question together. Okay, guys, let's look at this question here. It's a very once again standard question. Shut up, stop talking. And once again, it should have a very standard answer. Guys, first things first is you identify the information, right? This is going to be your mass. This is going to be your height. And they ask you to find gravitational potential energy, which everyone knows the formula by now, right? GPE is supposed to be equals to mgh, right? In this scenario here, it will be 0.4 multiplied by a 9.8 multiplied by your height and go ahead. Multiply by your height, and you're supposed to get a final answer of somewhere around 33.3 joules, right? Right. Everyone got this one? I think everyone got this one. Then the next question, which comes after the GPE. Hey, this is a very standard one. As soon as you see they want you to find the speed, guys. As soon as they ask you to find the speed, what principle is this again? Yes, it's a principle of conservation of energy, right? Which states that energy cannot be created nor destroyed, always transferred from one form to another. In this case, the first form will be your GPE, that is converted into your second form, which is your KE. Write this down first. Then after that, you realize that, oh, I can actually expand this formula a little bit more. GPE is equals to kinetic energy's formula, which is half mv squared, right? From here, literally substitute all the information in. 33.3 is equals to half multiplied by 0.4 multiplied by a v squared. And then, bam, it's mathematics time once again. How much do you get for your speed? 12.9 meters per second. Okay, I should write this way. Everyone's algebra here is okay, right? You don't need me to do it step by step for you guys, right? Good, excellent. Just what I like. Complete silence when I ask the questions. Okay, then after that, guys. Hey, everyone okay with this question? Anyone? Seriously, anyone don't understand this? And this is damn typical. In fact, this is like as easy as they get because they already guide you through step by step already. You know how the tough questions will be like? They'll give you something like this. Okay, this object, right, goes up a height of, I don't know, maybe like 10 meters. Find the speed of it falling down at the maximum speed. They'll straight away give you something like this. And in this case, it will be the exact same thing, which will usually come up in your paper too, guys. You're supposed to know that GPE is equals to KE, right? In this case, is mgh is equals to half mv squared. From here, a lot of students, they'll be like, hey, teacher, but then what? I don't have the mass. Which you don't need, You don't need the bloody mass, guys, because I've said this 1,000 times. Mathematically, the mass will cancel off each other, right? You did it right. Right. Then from here, literally just substitute everything in. 9.8 multiplied by 10 is equals to half, and then your b squared. And then once again, it's algebra. And you should be able to get your answers already. This kind of scenarios will come up more in your paper too. You do not need the mass, guys. Remember that in your exam. In fact, Wesley may just ask you the exact same thing. Okay. Then, next. In practice, the launch speed must be greater than the value calculated in 2. They said that the real launch speed should be greater than 2. The A2. Why? What's acting on the thing? Gravity and? Good. That in reality, guys, whatever we do here, you know this calculation that we do, right? We're assuming 100% conversion, which is never the case. There's no such thing as 100% efficiency. And because of that, in reality, the height or the speed will be much less. Why? Because there's other factors acting against it, right? Such as air resistance, and then energy loss to heat and sound, and even gravity. So you say, explain why. Air resistance acts on the object. Acts against the object. Okay, then finally, explain what happens to this energy as the model parachutist falls through the air at constant speed. Explain what happens to this energy here. It's a damn standard question once again. Now, where does the energy go again, Macy? Where does the energy go? Where does it go, Natasha? Good, very good. The energy is always converted into heat and sound, now guys. And you're basically supposed to write that energy converted to heat and sound. Okay. Please attempt the vector diagram. Question number 8, I think. Was it question number 8? Yeah, question number 8 then. Ask your Okay, guys, move on to the vector diagram. And for those who have forgotten how to draw this vector diagram, which usually is the case here, right? Oh my God, has this thing been blocking your view all this while? What the? Do you guys see the two answers just now? Oh, okay. All right. Okay. Anyways, guys, for those who forgot how to draw a vector diagram, you're first supposed to identify which direction this is and this direction, which will give you a resultant direction where? Yeah, it will be in between, guys. You'll have an in-between thing. So in the end, you're literally supposed to draw a vector diagram that looks something like this. Always draw the mini-map, right, for reference. Then after that, you're supposed to connect this point to this point and measure how long it is and find the speed from there, guys. Everyone, please attempt this question. I know all of you guys, or at least most of you guys, will be a bit lost in this question. I just want to walk around and see. Oh, you have exactly 10 minutes to attempt this one. Okay. Your what?
If we're done, this will be this.
Oh, because we like I click on switch on. Yeah, really.
Okay.
有，蛮肯定有。你知道走，they should be checking you. Yeah. It could do that in scale, but let me tell you, when you scale, you're going to be at least using up 70% of it. If they immediately you go to smaller profit. Yeah. I repeat, whatever scale it is, the online issues, I think 70% of the case given drawing is small to draw. So there's no use, let's just do what they got and use something. And again, we have it's very that's not a very easy run. This is a very next week. It's one of the is the game for you to see that the after this week, the thing you will buy after that. Bro, okay, let's think about it this way. Extend it to a hand. If I put this side and this side together, where do you go? You go in between, right? Oh. Yes. Oh God. Here we go. Cheers. Yes. Yes. Oh, it is one. Why didn't I know? It's what did it? Remove it where we made it. Yes, yes, very good. This is definitely acceptable. Yeah. Oh my God. The school make it go. Very right. Then you find it like out and this thing like a skill find it. I think it's and not being popular many of time. Yeah, only right. It is. Okay. One and swimming. Yeah. Find out the two reference here or here from the reference here. So like right angle from the regular back right. This is the regular back so how many? Yes, I use conflicts in that small area. It's open my hands and not set on them. One thing but I feel it only one thing to see. I'm speaking of but this is speaking given it's supposed to and the I mean, say I'm speaking broad, it's not that close to this is side, not place. Which one? Direction, yeah, you're confusing. Yeah. That's this thing. That. Yeah, okay. That's wrong. Yeah. Fortunately, this is because of what we have to. This life can take. Even people. It was. But one time also the market that was thinking. Yeah. Yeah. I think everyone here. Yeah. Oh, yeah. Sure. Well, this is you.
Guys, you have 3 more minutes to attempt the paper, please. If you have any questions, now will be a good time.
Oh, 这个好像没有在 line 上有的，所以那大家
哦，不是高低在那里。
那就是不理解，然后就是习惯。Then you got a scale, how much big scale will once the m equals to 0.5 meters per second, maybe. I don't know. Once the air equals to 0.5 meters per second. And then go away. You can go around. Those are the problem. We officers are.
Yes, you get answer. This is right, no? You need to use. Yes. You need to use at least 70% of the empty space. So like for example, if you want cm 1 meters per second, it will be too small already. So you just follow it up at once and use 0.5 meters per second. There is not only this function. I think but it's not wrong this function. This line exceeds the original with it doesn't start from there. No, nothing. This is the line you can free anything it's supposed to this point this end and this end should be and this end should be and this end and this end should be this end. Bro, and then this end. Guys, yeah. How much? 1 more minute to attempt it, then whatever it is. That's all. This is correct. I also it's a bit of a power. It's a bird. It's a then falls or feet in this case. Always it's fine. If I don't do anything, I see if I didn't make skill, if I can do so, my life there. Thank you. Go to the question together for those who are confused as hell. Let's go through it together, guys. Okay. Please, everyone, pay attention to this because every year Wesley like to ask this question, and every year the students they come back like, shit lah, this was the exact same question that came up for the exam. And if you're lucky, it might be the same one too. Okay, so first and foremost, what do they give you? Figure 3.1 shows water in the river moving parallel to the riverbank. This water is moving parallel to the riverbank at 4 meters per second. This is your 4 meters per second. And a canoe traveling in the river, for some reason, it is canoeing in this direction at a speed of 2.5 meters per second. The canoe travels 2.5 meters per second relative to the water and head at an angle of 38 degrees to the riverbank. Draw a scale diagram to determine the canoe's resultant velocity, guys. For those who do not know, if you ever have two forces acting, if I want to draw it simply, right, this is like all the way until here. I have one velocity in this direction, I have one velocity in this direction, right? The resultant velocity, force, or whatever it is, will always be in between these two things, guys, and you can test it out also. You can go to your friend, ask him to extend in two directions. One friend pulls in this direction, one hand pulls in this direction here. You'll notice that the guy kind of leans forward, right? Which represents that the final resultant speed should be in between the two. Everyone's got to look at him, pay attention, right? So from here, your idea is that this thing here should be representing this, and this thing here should be representing this. Time close to the border. Okay? Then you're supposed to have some trapezium here. First and foremost, once you have this mini-map, which I always like to draw and recommend, right? You must draw the scale first. And if you draw the damn diagram like this, right? You are wrong. Because you need to use at least 70% of the given space. So, if you try 1 cm represents 1 meters per second, for sure you're going to draw a very small one here, which is wrong already. If it's wrong already, what you do next is you go smaller. 1 cm represents 0.5 meters per second instead. Then you can start labeling, right? You can start labeling it here. If 1 cm represents 0.5, this should be 5 cm, right? And this should be 8 cm, this should be 5 cm, and this should be 8 cm, right? Then after that, you also realize that this angle is 38, right? That means to say this internal angle should be 142, right? 142, then this will be shit, how much? 38. This will be 142, and this will be 38. You're supposed to have all these parameters in place first. Then you can start drawing the whole thing already. By right, you should end up with something like this. This thing here, that is 8 cm. And then you measure 142 degrees here, and you draw a 5 cm line. Then you measure 38 degrees, and you draw another 8 cm line, and then you measure another 142 degrees, and you draw a 5 cm line. From here, once you have this information already, you only need to connect this point to this point, and you bloody don't draw it like an art diagram, One of you guys are drawing like this, and then like this, and then like this one. Which one is intersecting with which one? Bloody hell, you will definitely be wrong if you do it in the exam. It is definitely 100% wrong. And if you do that, you won't even get the scale. Once you have this, you measure how long this thing is, which will most likely be, how long was it again? It will be somewhere around 5.2 cm. Usually they give you a range on 5.2 cm. Then after that, what you do is you need to find the final resultant velocity, right? If just now 1 cm represents 0.5 newtons, shouldn't it be 10.4 instead? No. Oh shit. yeah. 1 cm equals to 0.5. So it should be what? 2.6? Is it 2.6? Oh, it is. It is actually 2.6. It is 2.6 for some reason. Right, because if 1 cm represents 0.5, then 5.2 cm must be representing 2.6 meters per second, right? A show of hands of how many got the final answer of 2.6. What did I give you? What did I tell you the answer was again? Just now, was it 2.6? Huh? It's correct. 2.1? It's acceptable. 2.85. A bit over the range already. The acceptable range is somewhere around 2.3 to 2.8. But I'll tell you why the range is wrong, because most likely one of your angles is not right, or your line is not connecting to the other line already. And then finally, they want you to find the resultant velocity. Do you get this one also? 37.5. Is it 37.5 degrees? Acceptable. Somewhere around there. You're supposed to get these answers. Okay, everyone, anyone that did not get this answer or is confused as hell right now, let me go and have a look at your answer. Then I can.
Okay, well, get rid of it. Then can I have a quick show of who's not staying for that max? Everyone is 1, 2. Everyone else is 3. Okay. Everyone else is staying for that max, huh? I think I can try to be as careful as possible because one misalignment of the angle already then go into different okay, everyone. Yes, that will conclude today's class, guys. Before we go, can we meme it up or not for the Sunday memes? Can I get the name? Okay, guys, if you have any questions, please feel free to send me a text message and clarify anything that you may not understand. But guys, if you have no questions, that's gonna be it for today. I'll see you guys some other time. Okay. See you. Are you still there? Bye bye. Oh, she said she's coming later. See you. So, okay, bye bye.